All right, welcome back to pycse. Today I want to talk about conditional and control statements in Python, which are ways to control the branches in a program or parts of a program that get run or not. And these are the statements that are if, elif, and else. And they take, like if and elif take arguments that are Boolean in nature or truthy or falsy. And so if something is truthy, then that branch will run, and otherwise it won't. So for example, I have in the little cartoon up here, if rain, then umbrella is equal to true. Otherwise, umbrella is equal to false. And so these are the ways we can control what happens in your Python programs. So let's take a look at some kind of classic ways to think about it in the simplest form. So let's say if something is true, let's print it's okay, and otherwise let's print nope. All right, so here true is a Boolean in Python, and so if it's true, this will print it's okay. All right, and that's what we get when we run this. And if I've changed this to false, then it's going to print nope. All right, so if this thing here evaluates to something falsy, then it goes to the else part of this, and otherwise it does what's in the true branch. Okay, so how do we use that in practice, right? So normally we combine this with the kinds of comparison operators or membership operators that I talked about before. So let's define a variable. A is 5, and now we could say if A is greater than 5, let's say A is greater than 10, then we'll print A is large, and otherwise we could say print A is less than 10. All right, so here A is 5. It is not less than 10, so this will evaluate to false, and we'll get the false branch down here. All right, and then if I say up here A is 50, then we'll get A is large. Right, so we have here a comparison operator that we use to control what happens here. Now, what if we need to have more than one option, right? So what if we need to see if A is greater than 10, we'll print A is large. But what if we want A between 5 and 10? To get that, we have to add the Elif statement. All right, so Elif is a way of adding a more than one condition. So we can have if this condition, do something, if another condition, do something else, if another condition, do another thing, and otherwise do the last thing. All right, so let's say if A is greater than 10, then we'll print A is large. A is large. And then let's say elif, let's say A is greater than 5. Then let's say print A is medium. And then we can say finally else print A is small. Okay, so here, let's go up here and let's say what A is. A is equal to 1. So 1 is not bigger than 10, it's not bigger than 5, we'll expect A to be small. Right, and now if I say, let's say 6, then A is medium, and if it's 60, then A is large. And we can have as many of these as we want. Maybe we want to make this one let's say this one's medium plus plus, and we can add elif A is greater than 5, print A is just medium. All right, so now let's see, 60 is still going to be large. If we have 8, then it's medium plus plus. If we have 6, just medium. And if we have 5, then A is small. And you can have greater than or equals, less than, you can combine these. There's lots of different ways you could structure this. And the main point is it goes down these in order. So it tries this one, then this one, then this one, and finally here for a equals 5 we get to the final else statement, which is everything else. So this is one way to do it. You can also nest these. So let's just look at nesting real quick. If a is greater than 10, we could say have another statement here. So here we're greater than 10, and now we want to maybe split on two other things. If a is greater than 20, print I don't know, let's just do a greater than 20. Else print a is between 10 and 20. And then we can go back down to here. So here this is now a is not greater than 10, so maybe a is greater than 7. Print medium. Else, let's just try this. This might be an error. Or it's going to return none. So let's say a equals 100 here. So here we get a greater than 20. And then if we have, let's say 12, then we get this result printing. If we say 8, then we get this result printing. And now if we have something that doesn't match any of these, nothing will happen, right? So if I say a is equal to 1, then we're getting this code block is not evaluating or returning anything. That's sometimes why you want to have the else statement. Sometimes called a fall through. So when none of these are captured, then you get into the final category. So that's the kind of short introduction to if statements in if, elif, else. And with this, we are almost ready to work on a numerical algorithm where we can do a calculation, combine it with a loop, use conditional statements to break out of the loop when we want to, and then print a result. And maybe that's what we'll do next time. We'll look at how to implement Newton's algorithm for solving an equation that is an iterative method that you have to loop repeatedly until a criteria is met, and that criteria will be defined by this. So let's look at maybe one example just to put that together. So let's say we want to, given a number, divide it by 2 until the product, or until that division is less than 1. Okay, so that would look like if we start with 10, we divide by 2 and get 5, divide by 2 and get 2.5, divide by 2 and get 1.25, divide by 2 and get 0.6 something, which is less than 1, and we want to break at that point. All right, so let's say n is equal to 10. Then we can say while n is greater than 1, so we're running a loop, we'll divide n by 2. So I'll do the n divided by equals 2. And finally, we will just print, look at n. Oh, that's interesting. Let's just restart this. That is a leftover from something I did before. One of the things I don't like about Emacs Jupyter is it does not make a new kernel for each file. All right, so there we have it. Let's print n for each one of these, and you can see that it does what I said. It gets 5, and then 2.5, then 1.25, and then this. So here we have the conditional. Now this wasn't exactly what I said we would do. This is the shorter one. Let's write another version of it. Okay, so for I in range of, let's say we'll allow up to 20 steps. Let's say n equals 10. So for each one of these steps, we'll say n divided by equals 2. And now if n is less than 1, then we'll break. Let's also print I comma n. And this will get us out of the loop and show us that result. All right, so that's how we can combine a for loop that we iterate for a bunch of steps, do something, have a condition. If n is less than 1, then we could break. And this is the beginning of many kinds of numerical algorithms that require you to stop doing something when you meet a criteria. Maybe you meet a tolerance or are below a certain threshold, and you need to use this condition to break out of the loop, or break out of a function to return, etc. All right, so that's it for today. This was a brief introduction to if, elif, else for using control statements to determine what part of your programs get run. Thanks for coming.